Hello everyone, welcome back to another video on amino acids. I'm going to be looking over into the structures of it. Before I go into the video, I would like to thank everyone for their positive feedback for my previous video. And in that video, I had gone over the properties and the classification of various amino acids, which would be a prerequisite to this video. You can check out that video in the iCard that I've provided over here. So now moving on. In this video, I'm going to be talking about especially about the hydrophobic amino acid, the structure and how to remember them easily. So this worksheet is freely available for you to download below. The backbone of each amino acid is given and we'll be looking into the functional group of each. So moving on. So the first and most easy amino acid, if you remember, is glycine. Glycine has a single letter code of G. Now before we go, I just have to mention that every amino acid has three kinds of names. The first name is the full name. The full name. This is what we will see everywhere, that is glycine, alanine, valine and so on. The second kind of name that will be given is a three-letter name that will usually be the first three alphabets of each amino acid. So for glycine it would be GLY, for alanine it would be ALA and so on. And finally you'll have a single letter code. Single letter code. And this would just usually always will be the first alphabet of each amino acid, but there are some exceptions when overlap occurs. So when it comes to it, I will talk about it. So the first simplest amino acid is glycine, and if you all recall, I've told that glycine is a non-chiral amino acid, and this is because the functional group for glycine is just a hydrogen atom attached to the alpha carbon. So this is your alpha carbon and it is just a hydrogen atom attached to it. So moving on. Then the next amino acid is alanine. Its single letter code is A. Now this is the first amino acid where we will notice that there is a beta carbon attached to your alpha carbon, and the beta carbon would usually be the methyl group. So this will be a beta carbon, and from here on out all amino acids will have a beta carbon, and we can go ahead and draw a beta carbon to all of the amino acids, or we can draw it when we come to it. But this is an easy way to remember. Now the next amino acid is valine. Valine starts with a V and its single letter code is V. Now an easy way to remember this structure is, since its single letter code is V, you just have to draw a V on the beta carbon and that's your structure of valine. So this is the structure of valine, where two methyl groups are there in the ending and the beta carbon attached to your alpha carbon. This is a simple structure of valine. So moving on. The next one is leucine. Now thing to remember is leucine, isoleucine and valine all have similar structures to each other. So if you know one, you'll easily be able to get the others. So how to draw leucine? Leucine has a similar structure to valine, but it's just an addition of an additional carbon atom. So from your beta carbon, this is your beta carbon, draw one more carbon atom and then add the valine. Just draw the V again. So you have one beta carbon over here, one more carbon atom over here, and two carbon atoms here. And that's your simple structure of leucine. So the next one is isoleucine. If you look at it, the first thing is iso. What is, I hope it's visible, one second. It should be visible now. So I hope it's visible. One second. Yeah, okay. So if you look at the first part, it's written iso. Iso means isomer. And what's an isomer? Isomers are chemical structures where the chemical formula is same to both, but their structure varies between them. So what occurs to get from leucine to isoleucine is, if you notice this carbon bond here, you just have to shift it to here. And that's a simple structure of isoleucine. So take this, and if you move it here, if this is your beta carbon, you'll get this kind of structure, followed by this line which is over here, and finally this line. So this is your structure of isoleucine. It's as simple as that. Another way to remember it is isoleucine has a single letter code of I. If you just remove the top part and the bottom part, you will get a structure something like this, and that's your functional group attached to your beta carbon. So moving on. The next important amino acid in the hydrophobic amino acids are methionine. Methionine is one of the two amino acids which has a sulfur group in it. But this sulfur group cannot form disulfide bridges in a protein structure. So how to remember the structure of methionine? Methionine has a single letter code of M. So just draw a sideways M. you can notice that the value of M looks kind of similar to a S for sulfur. So this is usually how everyone learns the structure. So we can start with drawing an S as the valley and drawing the other carbon atom. So this would be one carbon atom, this would be another carbon atom, which will always be attached to a beta carbon. So like I said, there's always a beta carbon for every amino acid except for glycine. And then draw your M structure S and attach this. Okay, so this is one beta carbon, this is one carbon atom, your second carbon atom, and your third carbon atom. Okay, so I'm sorry if this line didn't come properly, but remember there are beta, one more carbon, sulfur, and then finally another carbon atom. So moving on, phenylalanine. Phenylalanine is a aromatic hydrophobic amino acid, and we can easily derive the structure by just looking at the name itself. We have phenyl and alanine in it. So we already looked at before what alanine structure is, so we can just go ahead and draw it. So just draw a methyl group as your functional group, and that's your alanine structure. But what is phenyl? Phenyl is nothing but when you have an R group, and to that if you attach a benzene ring, that is a phenyl group. This is phenyl. So if you try to recreate it to alanine, if you change this whole thing to alanine, we'll get phenylalanine. So just remove this CH3 because carbon can only have 4 valent, it can be only tetravalent. So it's just CH attached to a benzene ring. And this is a structure of phenylalanine. So moving on from so it's a simple structure. From phenylalanine, let's look at tyrosine. Tyrosine, and it's important to remember this structure because it can come for interview questions also. Phenylalanine and tyrosine are very related to each other. The reason being, tyrosine is a derivative of phenylalanine. So phenylalanine is actually an essential amino acid which we have to take in from external sources by food and so on. But tyrosine can be synthesized in our body from phenylalanine that we are intaking. So a derivative means we just have to do some sort of modification to the structure to get tyrosine. And this modification is a addition of a hydroxyl group. So as always, just draw the structure of phenylalanine, and to the end just add a hydroxyl group, that's an OH group. And this is the structure of tyrosine. Remember that this is a non-essential amino acid and it is a derivative of phenylalanine. So moving on, so these two are again aromatic amino acids, and the third one is again tryptophan. So tryptophan, remember that it has an indole group to it. Alright, so how to remember it? Tryptophan has a single letter code of W. So it's a simple way, just draw a wide stance W. Now what is an indole group? It has both a 6-membered ring and a 5-membered ring. So let's start with the 6-membered ring, which is the easiest to draw, which will be a benzene structure. So it will look like a benzene structure, I'm sorry. So on this, just make your 6-membered ring, simple. Now you just have to add a 5-membered ring here. Remember the 5-membered ring has a nitrogen group on it. So put the N over here and make the 5-membered structure. So you have 1, 2, 3, 4 and 5. And this is your 6-member. Now this is not it. We have to make the double bonds to make it conjugated. 1, 2 and here. If this is already taken, alternate here. And from here, this atom, attach it to your beta carbon. So as always, remember there's always a beta carbon from everything. From here, draw to here and make the W. Wide stance W. Draw the 6-membered ring. Draw the N. And draw the 5-membered ring. Make the conjugate bonds. And it's as simple as that. Now, those observe who just notice that you can notice that usually nitrogen will have a lone pair. And you can ask a valid question. If this has a lone pair, shouldn't this be a polar molecule? And it cannot be a hydrophobic amino acid thus. But it's true that what you have just noticed, it's a very good observation. But in this case, although tryptophan is slightly polar in nature, the reason it comes under hydrophobic amino acid is because this lone pair actually participates in the resonance stabilization of the structure. Therefore, it actually acts like a hydrophobic amino acid and is actually very slightly polar in nature. So you can consider it in this group. So I hope this is easy to remember. Just practice it a few times and you'll be able to get it. And finally, you have your outlier protein amino acid, which is proline. Now, proline is actually also called an amino acid. This is due to the fact that it has an amino group on it. Now, over here in all other cases, this functional group is actually free from the it's only attached to the main chain by this beta carbon. But in this, the functional group itself attaches back to your alpha amino group. This is your alpha amino group, this is your alpha carbon. Now, how to remember it? If you have your proline starts with the alphabet P, so this is a big P. Imagine this is your alpha amino group. Okay, and imagine this is your alpha carbon group. So now you have this to this line. Now you just have to remember this also is a five member structure. So just draw 5 more carbon atoms and attach everything. And this is the structure of proline. So if I just draw it here, from here already this bond is already made over here. Then just go up one, go here, and go here. And this is the structure of proline. This is not a double bond, please remember that. This is everything is a single bond over here, and this is the structure of proline. Now it is important to know proline, because of this structure, it's actually steric hindrance is very high, and proline and glycine are actually known as alpha helix disruptors, because if you place them in an alpha helix, that is in a protein secondary structure, if an proline or alanine proline or glycine residue occurs over here, the alpha helix becomes destabilized and will unwind. Okay, it's always good to remember this. Now, an easy mnemonic to remember all the hydrophobic amino acid is just to know GP, WYM, we fail. How do you remember this? Is suppose imagine your class teacher gave you a test where she gave you all the hydrophobic amino acids, but since you didn't know the structures of each, you ended up failing it. I hope this never happens, but this is a good way to remember it. So you go to your friend and you ask them immediately, what do you mean we failed this test? So GP is just glycine and proline. G for glycine, P for proline. Then WYM, is, if you look in the text format, it will be what you mean, and V as in V like that, and fail as in you failed the test. So GP, what you mean, we fail. That is your hydrophobic amino acids. And what does it mean? G is glycine, P is proline, W is tryptophan, Y is tyrosine, M is methionine, B is valine, F is phenylalanine, A is alanine, I is isoleucine, and L is leucine. So this is a simple introduction into how you can remember the structures of hydrophobic amino acids. Feel free to watch it again and again. In usually 2 trials, you'll be able to remember all of them easily. In my next video, I'll be looking into the hydrophilic amino acids and how you can remember the structure very easily. So thank you very much. Feel free to ask any questions down below, and you can watch my previous video here if you have not. So thank you. Bye.